Next, Dr. Starmer, I would
Yeah.
like to ask about, like, since you're a PhD in bioinformatics,
Hmm.
so we we have had from basic neural networks to say language models with memory retrieval now. So, what kind of further developments do you expect to see in the future of AI, like being inspired by biology? Are you expecting
Uh, so AI being inspired by biology,
by
is that what
biology?
you're
Yeah.
asking about?
Yeah.
What's actually, the trend, as far as I can tell, is for AI to actually get further and further and further away from biology. So like neural networks, the original concept was like, oh, we'll make something sort of like a neuron.
Yeah.
And they did. They tried to model sort of a basic neuron, including using something called a sigmoid curve in those equations of how a neural network should work. They incorporated a sigmoid thing. Well, the reason why they incorporated that was the sigmoid did a relatively good job. That shape. So a sigmoid is sort of an S-shaped line on a graph, um, and they included that S-shape line in the equations was because that's sort of the way neurons behave. When you
Like an
trigger a
activation.
neuron, yeah, when they activate, when you trigger a neuron, it takes a little bit of time for it to ramp up. It's not like instantaneous flooding of signal. It like ramps it up, and then it hits some sort of like linear state where it's kind of like sending the signal at a constant rate, and then the signal starts to taper off. But you know what I'm saying? So they had this idea of like, this is how a neuron actually works, and we can model it with this mathematical equation for this S shape, and that's great. But it turned out that that S shape was sort of like getting in the way of neural networks doing what they needed to do. And when you use that S shape, neural networks could not become what's called deep, in that they were limited in terms of the kind of problems they could solve with the S shape. And so about a little over 20 years ago, they said, okay, let's get rid of the S shape, and they switched to something called a ReLU activation function, which is a bent shape, and it
Yeah.
doesn't saturate, and it sort of like is all or nothing, and it's very non-biological in how it works. Um, and and once they were like, okay, we got rid of this thing that sort of linked neural networks to actual neurons. Once they got rid of that, all of a sudden neural networks started performing much better. They could get much deeper, and they could approximate much more complicated functions and much more complicated data sets. And so that was like a big step away from biology. And when you and since then, they were like, okay, now we're using activation functions that are not like what a neuron actually does. We're using this ReLU thing. And then sort of around 2013, maybe 10 years ago, that's when they started bringing in attention. Um,
Yeah.
and once they started bringing in attention, and once they started bringing in transformers, they went from neural networks kind of having this network that would kind of resembled how neurons would plug into each other, and relate to each other, to something that's like very unbiological. I mean, I'm no neuroscientist, but I know that the connections used to be very simple and just sort of like, we multiply this value by something, so we're basically amplifying it or we're attenuating it, and then we add some offset, and that's kind of what happens in biology. Where a signal can get amplified or
Yes. Yeah. Yeah.
attenuated. But now what we do we used to have these very simple functions along the connections, and now we've got like square root functions. We're taking dot products left and right, and I guess dot products, you can simulate that in a normal neural network, but we're starting to add layers of functions that no longer
Yeah.
have anything to do with biology and how a brain works. So and as a result of yet another step away from biology, we created transformers, which have given birth to the large language models that we have now. And so, from my perspective, what I've seen is a relatively gradual shift away from biology. And the further we get away from biology and
Right.
pretending to actually model something, the better the models work. Now, that being said, it's possible we'll take this sort of like getting away from biology as far as we can get, and we'll hit a wall and where we can't get any further. And they've got to maybe then go back to first principles and
Back to
go, well,
basics and
actually, our brains are fantastic. They're amazing what they can do. Maybe there is something there, and maybe we have new techniques to model the brain. But I feel like neural networks have been successful in because they've gotten
so far.
further and further away from biology. But maybe there's a way to either create something new based on biology again, and that would be pretty exciting, I think, in my opinion. As a my background is in science,
Yeah.
bioinformatics. I was a genetics professor, so I'm personally interested in something that, like, I think it'd be cool if we had something that was actually lifelike or actually biologically inspired. That to me is more interesting than something that's just a pile of equations. But we'll
Do
just
you
have to
think
see.
yeah. Do you think it would
Yeah.
have to be a whole different architecture as well? Because the
I
current transformer architecture is totally different.
Yeah, exactly. I don't know. I mean, presumably, I think it would. I think someone would have to maybe start from scratch, just because I mean, partly because that's sort of the way we do things to begin with, but also because it would help us keep from taking shortcuts. If you're just like, if you're like, oh, we've got this transformer, it already does all this really cool stuff. Let's just
Yeah.
plug it in. The temptation to kind of cut a corner and not really be innovative in terms of the design is probably pretty strong. So it might be good to see if someone's like had a really disciplined approach to being like, no, 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 well, let's actually try to model this brain and see what happens. And maybe nothing happens. Maybe we don't have the computing power yet, but that could change. I mean, so far computing power has just sort of like grown rather than gotten smaller. And so I really don't know what to expect, but I would presume that someone might come up with a new fundamentally different architecture. I feel like neural networks are sort of going their way, and it'd be very difficult for them to like change course and all of a sudden become biologically inspired again.